All right, second part of fundamental theorem of algebra. I am recording now, so I'll upload this later, but this is not terribly difficult. We got through it first period, and they started to work on some things. We talked earlier in section 2.4. If we had something like this, if you guys had 2 plus 3i over 5 minus 6i, right? What's the problem here? What's the problem? I in the denominator. So we had to multiply by 5 plus 6i, right? And when we multiplied by the complex conjugate, the i's canceled out. So that's what we're going to talk about today. When you guys, you're going to be given all the zeros of the function. I'm going to tell you what x equals, and then you're going to work backwards to find the polynomial. Just a lot of algebra today. But when you're given a complex zero, if they tell you one of the x's is 2i, you have to account for the complex conjugate. You also have to say, oh, negative 2i. If they give you an irrational root, like square root of 3, you also have to account for negative square root of 3. I'll show you what I mean by that in a second. All right, so let's just go through. You're going to have a problem that says, here we go. Here are the zeros. You have a fourth degree polynomial function. What does the polynomial look like? First of all, something is the fourth degree. What's the highest exponent? 4. So the zeros they gave you are x equals negative 1, x equals negative 1, x equals 3i, and since 3i is complex, you have to account for the conjugate. So they told you it's also x equals what? Negative 3i. You have to, they're not going to always tell you it's plus and minus. You have to remember that. So all you're doing here, guys, is writing these as a product of linear factors, which is what we did yesterday. Then you're going to multiply them together to find the polynomial. So what does this first parenthesis look like? If I bring this negative 1 over, it's x plus 1. If I bring this over, it's x plus 1. If I bring this over, it's x minus 3i. And if I bring this over, it's x plus 3i. So you are writing a polynomial function. You are writing the original problem. It's really what you're doing. You guys can FOIL this together any way you want to. I would keep the real stuff together. So x times x is x squared. X times 1 is plus x. 1 times x is plus x. And 1 times 1 is 1. Agreed? Combine like terms. X squared plus 2x plus 1. Now, deal with the imaginary stuff. X times x is x squared. X times 3i is plus 3xi. Negative 3i and x is minus 3xi. And negative 3i and positive 3i is minus 9i what? Squared. As soon as you see i squared, what do? Cross it off and change the sign. And then what happens with your 3xi's? They cancel, which is what should happen every time. So you're left here with x squared plus 9. You guys have never seen a polynomial that says, here, factor this or whatever, and it has i's and stuff in it. So when you multiply your complex conjugates together, that's why you have to account for the complex conjugate, so the i's will cancel. And then now you just FOIL again. So x squared and x squared is x to the 4th. X squared and 9 is 9x squared. 2x and x squared is 2x cubed. 2x and 9 is 18x. 1 and x squared is plus x squared. And 1 and 9 is plus 9, right? Yes, you guys agree? So your answer should start off with f of x, g of x, h of x. You're writing a polynomial function. And then combine like terms. So you have x to the 4th. What else? Plus 2x cubed. 10x squared, because you have a 9x squared and a 1x, so plus 10x squared. Plus 18x, plus what? Plus 9. Perfect. So this is not incredibly difficult. Today is not super hard. It's a lot of algebra. A ton of places that you guys could make mistakes. So just take your time when you're FOILing. Make sure that when you multiply, 9 times 2 is 18, not 11 because you added or something silly like that. All right, I'm going to do these two examples here. I'm going to do 2 and I'm going to do 4. Now notice with number 2, guys, Did they give you an imaginary root? Number 2, is there an imaginary? No, but there's an irrational one. So we have to account for a positive and negative irrational because you don't want square roots in your original polynomial. So this is really saying that I have x equals what? Negative 5. I have x equals the square root of 3. And I have x equals what? Negative square root of 3. If you forget to do that, once you go back and FOIL, you'll realize, oh wait, I forgot something because you shouldn't have square roots. So if you're going to write your 3 binomials, would you guys agree with me? This is x plus 5, x minus the square root of 3, and x plus the square root of 3. Now, you can FOIL any way you want. I'm going to get rid of the radicals first, so I'm just going to rewrite x plus 5 and then deal with my second 2 parentheses. X times x is x squared. X times root 3 is plus x root 3. Negative root 3 in x is minus x root 3. And then what's the square root of 3 times the square root of 3? 3. It's the square root of 9, which is 3. So what happens with your x root 3's in the middle? They cancel, which is exactly what you needed to happen. So you have x plus 5. And then here I have x squared minus 3. And then to write your final polynomial, you're going to just FOIL that together. So x times x squared is x cubed. X times negative 3 is minus 3x. 5 and x squared is plus 5x squared. And 5 and negative 3 is minus 15. So in order to get full credit, to write your answer correctly, you need to have f of x, g of x, h of x, however you want to, and then write everything in standard form. So x cubed plus 5x squared minus 3x minus 15. Does that make sense?
The only thing I don't get is, like, why are you doing a negative square root of 3 and a positive square root of 3 when there's only positive?
Because whenever they give you an irrational root or an imaginary, they're also giving you the opposite. They just won't write it. You have to account for it. You have to remember, ooh, I got to write that down. Yeah, talk to me.
So like on the test, will it tell you like how many, like if it's
No.
X to the 4?
It'll say, given the following zeros, so then you have to know, ooh, I got to remember. Just you have to have plus or minus if it's an irrational root, and you have to have the conjugate for imaginaries. So like number 4. Number 4 is a long one because you have 2 imaginary roots, right? So the first thing you should do is write out what you have. You have x equals 3i, which means you also have x equals what? Negative 3i. So then you have x equals 2 plus I, which means you also have x equals 2 minus I. And then you have x equals negative 4. The real ones, you just have to write one time. So now when we're working backwards, this becomes x plus 3i. And this is x, whoops, I forgot this one over here. So this is x minus 3i and x plus 3i. Now watch what happens when you bring this one over, guys. Notice in both cases, the 2 is what kind of a number? It's a positive or negative? It's positive. So when you bring this over, this becomes minus 2, correct? Then it would be minus I. When you bring this over, it becomes x equals, minus 2 plus I. The first sign, when you have a complex where it has both an imaginary piece and a real piece, the first sign will stay the same. The second sign is the one that changes. And then here, you just have x plus 4. But notice how when you brought this over, since it was positive, it's going to be negative in both of them. It's that second sign that changes. So in this case, I would take this piece by piece. Do the first 2, the pink ones. X times x is x squared. X times 3i is plus 3xi. Negative 3i and x is minus 3xi. And negative 3 and positive 3 is going to give me minus 9i what? Squared. Cross off the I squared, change the sign. What happens with a positive and negative 3xi's in the middle? They cancel. So this is just x squared plus 9. You don't want any i's there, so that's good. You guys did a good job. Now I'm going to show you how to FOIL this out, the next one, and then I'm going to show you a shortcut. And I'm only going to use the shortcut after that, so I just want you to see. But if you're going to go the long way, all right, you're going to go the long way here. X times x is x squared. X times negative 2, negative 2x, and x times I is plus xi, okay? So negative 2 and x is minus 2x. Negative 2 and negative 2 is plus 4. And negative 2 and I is minus 2i. And then you have negative I and x is minus ix. Negative I and negative 2 is plus 2i. And then negative I and a positive I is minus I squared. As soon as you see I squared, what do? Cross it off, and I'm going to change that. So this is going to be plus 1. Now watch what happens here, guys. What can you combine? Anything with x squared? No. So you have x squared. I have a negative 2x and a negative 2x. This gives me minus 4x. Good job. Bless you. What happens with a positive xi and a negative xi? They cancel. What happens with a negative 2i and a positive 2i? They cancel. So what are you left with here? 4 plus 1 is 5. And then don't forget your last parenthesis over here of x plus 4. Now, again, a huge, big, yucky problem, but have you done everything you needed to and got rid of all of the i's? Yes. So now you would just multiply all of this together. I can do it in a minute if you guys want me to. I'm really not focusing on, you guys can all multiply, I understand that. But I want to show you, because I want to get to the next part so you guys can see it. I want you to see how to combine using the shortcut. Do you want me to multiply this out just to finish it? Yeah? Or no? Yes? Okay. Let's do it real quick. X squared times x squared is x to the 4th. X squared and negative 4x. Negative 4x cubed. X squared and 5 is 5x squared, okay. 9 and x squared is plus 9x squared. 9 and negative 4 is minus 36x. 9 and 5 is 45. All right, so you have x to the 4th minus 4x cubed plus 14x squared, yeah? Minus 36x plus 45. And then I'm going to move this to the front just because I like it out in front. And then what do I do with x plus 4? Foil it in. So x times x to the 4th is x to the 5th. X times this gives me negative 4x to the 4th. X in here is plus 14x cubed. X in here is minus 36x squared. Here and here is plus 45x. You guys with me? Okay, so now 4 times x to the 4th is plus 4x to the 4th. 4 times negative 4 is negative 16x cubed. 4 and 14 is what? How much? Say it again. What's 14 times 4? Guys?
56.
Thank you. 56. X. What?
Squared.
Okay. What's 36? Negative 36 and 4? 140 what?
4.
X, and then 45 and 4. 180. All right, now the possibility that I would give you something like this on your test, not likely, because it's really long. But now you combine like terms. So x to the 5th, I have a negative and a positive 4x to the 4th, so what happens there? They cancel. I have 14x cubed and a negative 16x cubed gives me negative 2x to the 3rd, good. Negative 36x squared and a positive 56, so plus 20x squared. 45 minus 144. 99, good. So negative 99x and then plus 180. All right, so there, that's your polynomial. But all that is, guys, is just multiplying. It's a lot. I understand that. I'm not going to give you one that long.
We don't have calculators on the test, right?
Huh?
We don't have calculators.
No, I'm not going to give you one like that. Just the process is what I want you to see. Now, I want to go back to this, and this is going to take us to our next thing. If I have two roots here, I have x equals 2 plus I. What's my other root that I have to account for? 2 minus I, right? So when I bring these over, this whole root is positive, so when I bring it over, it becomes negative. So this is x minus, and it's really 2 plus I that I brought over. And this is x minus 2 minus I, right? So you have to distribute this negative, so this becomes x minus 2 minus I and x minus 2 plus I. Every single time, I'm showing you why mathematically that works, but every single time when you bring a root over, if it's positive and you bring it over, the first sign is negative for both of them, correct? If it was negative, you bring it over and the first sign is positive. But always the sign is going to be, the first sign is the same, the second sign is one that changes. However you guys want to look at it, it's fine. You don't have to distribute that negative. But if I gave you guys this, if I said x plus 2 times x minus 2. Without foiling that, what does that become? X squared what? Minus 4. Difference of squares, right? Where you square the first term, square the second term, put a minus sign in the middle. Every single time you guys multiply complex conjugates, the same thing happens. Do you notice how you have in the front of each parenthesis, do you see how you have x minus 2? So you could write that as x minus 2 squared. What do you have at the back of each parenthesis? I, so that's I squared. And difference of perfect squares means you put the minus sign in the middle. Every single time you multiply complex conjugates, that will happen. So if you FOIL this out, x minus 2 times x minus 2, that gives you x squared minus 4x plus 4. Then you have minus, well, what's I squared? What do we do with I squared? You cross it off and change this to a what? So you have x squared minus 4x plus 5, which is what we got right here. Without doing this whole thing. I'll do another one so you guys see it. If you have a complex conjugate, if they tell you you have x equals, say, negative 3 plus 2i. All right, you have to multiply these together. Well, what's the complex conjugate of negative 3 plus 2i? Negative 3 what? Minus 2i. So when you bring this whole root over into your parenthesis, do you guys agree this becomes x plus 3? Yeah? So then you could say minus 2i. So when I bring this one over, it becomes x what? Plus 2i. The first sign stays the same. The second sign always changes. So if you were going to FOIL this together, x times x times 3, x times 2i, you could do that. Or you could just say, oh, this is the difference of squares. I have x plus 3 squared minus, what's the second term? What's that term? 2i. Don't worry about the sign because the pattern will work itself out. So if you FOIL x plus 3 times x plus 3, that gives you x squared plus 6x plus 9 minus, this 2 goes to both of these. So what does this become? 4i squared. What do you do with I squared? You cross it off, change the sign. So this becomes x squared plus 6x plus 13. If you don't like that, if that doesn't make sense to you, if that's confusing, then multiply the whole thing out. Make sure all the xi's and all that stuff cancel out. But it's time saving to learn the pattern. It's just the first thing, parentheses squared, minus the second thing, parentheses squared. That's it. All right, moving on. The next concept is you're going to be given a polynomial. All right, this is a polynomial, correct? How many answers does this polynomial have? 4. You are going to be given 2 of them. you're going to find the other two. The beauty about this is you do the exact same thing every single time. Another thing that is great is this will always work out perfectly. If it doesn't, then you did something wrong. So you can go back and be like, wait, something messed up. The first thing you're going to do is say, okay, here's the zeros that they gave me. They're always going to give us 2. They gave me a 0, x equals 1 plus 3i. And you're going to tell me they didn't give me 2. Yes, they did. What's the other 0 they gave you? 1 minus 3i. They're always going to give you the complex ones, and we're going to work backwards to find the real ones. So step number 1, you write down the 2 complex zeros they gave you. All right, step 2, we're going to multiply those together. We got to get rid of those i's. So when I multiply this together, when I bring this whole root over here, one of my parentheses is going to be x minus 1 minus 3i. What's my other parenthesis going to be? X minus 1 plus 3i. The first sign stays the same, second sign changes. Now, you guys can FOIL this together if you want. I'm going to use the shortcut. What's the first term? X minus 1 squared. What's the second term? 3i squared. Put a minus sign in the middle. So this is x minus 1 times x minus 1, which gives me x squared minus 2x plus 1. And I have a minus sign. Now remember, this 2 goes to the 3 and to the I. So what is 3i to the second power? Hi. What does that become? 9i squared. When you see I squared, what do? You cross it off and change the sign. So this becomes x squared minus 2x plus 10. All right, that is step 2. Step 1 is write down your zeros because they're going to give you 2. Step 2 is multiply those together. So now we're going to go to step 3. What is step 3? Well, we're going to take x squared minus 2x plus 10, and you're going to divide it into the polynomial that they gave you. So x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. And you're going to do long division. Now, this will work every single time. You should not get a remainder. You're going to get an expression that will help you find the 2 remaining zeros. This is a long process, I understand. It is a pain, I understand, but it's important. So x squared into x to the 4th. X squared times what gives me x to the 4th? X squared. Okay, I'm going to write up here above my x squared. Get your subtraction ready before you multiply. So x squared times x squared is x to the 4th. X squared and negative 2 is negative 2x cubed. And x squared and 10x is plus 10x squared. Agreed? Before I subtract, what I have to do with that minus sign? Distribute, 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 distribute. So this becomes 6x squared minus 10x squared. It's negative 4x squared. Negative 3x cubed plus x cubed is negative x cubed. And then what happens to your x to the 4th? They cancel, and then you bring down your plus 2x. So again, first term into first term. X times what? Sorry, x squared times what gives me negative x cubed? X squared times what gives me negative x cubed? Negative x. Perfect, guys. So negative x times x squared is negative x cubed. Negative x and 2x is plus 2x squared. Negative x and 10 is minus 10x. Before you subtract, what do? Distribute, distribute, distribute. So what's 10x plus 2x? 12x. What's a negative 4x squared and a negative 2x squared? Negative 6x squared. X cubes cancel. Bring down your minus 60. One more time. First term into first term. X squared times what gives you negative 6x squared? Negative 6. Perfect. Get your subtraction ready. Negative 6 and x squared is negative 6x squared. Negative 6 and negative 2 is plus 12x. Negative 6 and 10 is negative 60, yeah? What do I do with my negative sign? I distribute, 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 distribute. What's a negative 60 and a positive 60? What's negative 12x, positive 12x? What's negative 6x squared, positive 6x squared? So this is what you have left over, x squared minus x minus 6. We still haven't answered the question, but we're almost there. You already have 2 of the zeros, so now you take this, x squared minus x minus 6, and set it equal to 0. Every single time this will factor. What are the factors of negative 6 that multiply to give me negative 6 but add to give me a negative 1? Minus 3n plus 2. So your other two x's are x equals 3 and x equals negative 2. In order to arrive at those two, you have to do that process. So number 1, you account for the 2 complex zeros that they gave you. They'll give you one of them, you account for the other one. Then you multiply those 2 complex together. You take that polynomial and divide it into the given, and then you factor what's left over. Very long process, but you do the exact same thing every single time, and it'll work out, I promise.
So the 4 answer would be 1 plus 3.
Mm-hmm. I'll do example 1 on the video, but I'm going to do example 2 with you guys now, and then I'll let you work, and I'll do example 1 in a little bit. All right. First of all, look at this, guys. How many answers should I have for this problem? I should only have 3. So they gave me x equals negative 2 minus 5i. Since they gave me that one, what else did they give me? X equals negative 2 what? Plus 5i, okay? So I'm only now going to find one more 0. This one's not as long. So I have to take these 2 and I have to multiply them together. So when I take this, it's a negative 2. When I move it over, what does it become? Positive. So this would be x plus 2 plus 5i. What's the other one? X plus 2 minus 5i. That first sign stays the same. The second sign will change. So now if we do, get your setup for our shortcut. What's going in the first parenthesis? X plus 2, good. What's going in my second parenthesis? 5i, perfect. So if you're going to FOIL this, x plus 2 times x plus 2 gives me x squared plus 4x plus 4. You guys can write it out and FOIL it. Then I have minus, well, this 2, remember, goes to the 5 and to the I. So that becomes what? 25 what? I squared. When you see that I squared, you do what? Cross it off and change the sign. So you're left with x squared plus 4x plus 29. Okay, perfect. Yes, sir.
Is that the only way to do it? Could you just factor the normal way?
You could just FOIL it the normal way. Just takes a long time. But yeah, if you wanted to go x times x times, yeah, that's fine. All right, so I'm going to take my x squared. Was it 4x plus 29? And I'm going to divide it into this long thing, x cubed plus 11x squared plus, God bless you, 57x plus 203. So we already have 2 of the zeros. We're only going to end up finding one more. So first term into first term. X squared times what gives you x cubed? Just plain old x. I'm going to put it right here above my 57x. Get your subtraction ready, and then multiply. X times x squared is x cubed. X times 4x is plus 4x squared. And x times 29 is plus 29x. Before you subtract, we have to distribute, 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 distribute. 57x minus 29x is 28x. 11x squared minus 4x squared is 7x squared. My x cubes cancel and bring down your positive 203. Same thing, first term into first term. X squared times what gives you 7x squared? Positive 7. Good, so plus 7. 7 times x squared is 7x squared. 7 times 4 is 28. What do you guys think 7 times 29 is? It is 203 again. Before you subtract, distribute, 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 distribute. What happens with a positive and negative 203? Cancel. What happens with 28 and 28? Cancels. What happens with 7x squared, 7x squared? Cancels. So you're left with x plus 7. What do you do with that? You set it equal to 0. So what's the other x value? Negative 7. It's not incredibly difficult. It's just a pain. And if you make one little mistake, it's like, oh, seriously? But really and truly, guys, you do the same thing every time. Take your complex 0. Write down the conjugate. Multiply them together, long division, then factor. Every single time. Sound good? All right. Okay, this last one, we're going to do the exact same thing. We have x equals 3 plus 2i, so I have my other 0 of x equals 3 minus 2i. We're going to multiply them together. So when I bring this root over here, this becomes x minus 3 minus 2i. And this becomes x minus 3 plus 2i. So we're going to go ahead and get our little shortcut set up. The first term, x minus 3 squared, minus our second term is 2i squared. So when you FOIL this out, you get x squared minus 6x plus 9. Minus, this 2 goes here and here, so it's 4i squared. We're going to cross off I squared and put a plus sign here. So this becomes x squared minus 6x plus 13. So now we're going to take that, x squared minus 6x plus 13, and we're going to divide it into x cubed minus 11x squared plus 43x minus 65. Now again, guys, the highest exponent here is a 3, so we're going to find 3 answers. We already have 2 of them with our complex, so now we're going to find the last one. So x squared into x cubed goes x times. Get your subtraction ready before you multiply. So x times x squared is x cubed. X times negative 6 is negative 6x squared. And x times 13 is positive 13x. We're going to distribute, 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 distribute. So 43 minus 13 gives me 30x. 11x squared minus 6x squared gives me negative 5x squared. X cubes cancel. We bring down our negative 65. So now again, first term into first term. X squared times what gives me negative 5x squared? That's going to be negative 5. Get your subtraction ready before you multiply. Negative 5x and x squared is negative 5x squared. Negative 5 and negative 6 gives me positive 30x. And negative 5 and 13 gives me negative 65. And then we're going to distribute our negative. So distribute, change all the signs. So negative 65 and positive 65 is 0. Negative 30x and positive 30x is 0. Negative 5x squared and positive is 0. So we're left with x minus 5. And we set that equal to 0. So your other x value is x equals 5.